So I zoomed out, so I was trying to make it so you could see the graph and the problems at the same time. So like when I'm pointing to stuff, you can see it, but then that makes it smaller. So I don't know, we'll just do our best and see how it goes. So this one is saying we want to go to 6 from the left side. So here's 6, and you want to just kind of cover up everything else. Going to 6 from the left would be to this point right here. So -2. Treat this like your quiz dress rehearsal. Maybe like grade yourself, like give yourself checks or X's, all right? And then this one is 6 overall. It's not sided. So what did you think for that one? Yeah, because from the left, it's down here, and from the right, it's up here. So overall would be does not exist. Cool. Limit as x approaches 3 of the function. So here's 3. It's an asymptote. And does this say from the left or right? It does not. So that means it has to be does not exist. And that is tricky because it's like, well, both sides are going down. So wouldn't the answer just be -infinity? But those two arrows are never going to meet up. So you, unless it's sided, you'd have to say does not exist. All right, limit as x goes to -infinity. That's the left side. That's end behavior. You've been doing that for several years now. Where is this leveling off? 3. Good. And then limit as x goes to +infinity. So this side just keeps on going up. So infinity, yeah, +infinity. Those are your end behaviors. All right, limit as x goes to -4, and it is not sided. Yep, asymptote, so it does not exist. And then we have -4 from the right side. So that we can answer. From the right side, +infinity, going up. All right, limit as x goes to -3. Nothing weird is going on there. It's just going to be that point. It'll just be 0. Okay. 6 from the right. So we're back over here to 6. If you go from the right, you're headed towards where this hole is. That's fine, though. If there was a point, you would land right on it. So the behavior is going towards that. And so 3. All right. Limit as x goes to -7. Nothing weird is going on there. So it's just where that value is. If you wrote 3 or 3.5, or I don't know, what did you guys put?
Oh, -7?
Oh, it's -7. I looked at +7. I'm sorry. -7. Oh, well, that one would be 0. Sorry, I looked at +7. Limit as x goes to 0. So yeah, we'll just say like -3.5. Good enough. And then -4 from the left side going down, so -infinity. So that's calculus. These next ones are algebra. This is just where the actual point is. So f of -4, there's an asymptote, so we don't have that. F of -3 is 0. F of -1, little tricky for that one. Where is your actual point for -1? At 1. It's that floating point. And then for 6, it's a jump, but the actual point is down here at -2. Cool. All right, and then these ones are your yes or no. Is it continuous or not? The yes or no is going to come to you by instinct. It's the notation that's hard. Oh, let's review our 3-part definition. What was rule number 1? Those need to be closed while I'm going over stuff. There has to be a point. There has to be a limit. And then they have to equal each other, right? Okay, so if it doesn't equal, you have that like no parking sign kind of thing. All right, so what did you say for -3? Yes or no?
Yes.
Yes, good. And then life is good. You get to just move on. All right, -1 is no. There is a point and there is a limit, but they don't equal each other. Okay, so f of -1 does not equal limit as x goes to -1 of f of x.
Is it interchangeable?
You can, if you wrote that the other way around, that's fine. I always start with the point because I'm always like point, limit, they agree. So I start with the point, but I mean, yeah, obviously you can put it the other way around. All right, x equals 3 would be a no. What would be your reasoning for? Yep, good. There's not a point there. All right, and then at 6, we have a jump. There is a point, but there's not what? A limit. So limit as x approaches 6 of the function does not exist. And do you remember we talking about how you like can use a test to help you take a test? Like all this notation, if you look back up at these problems, like for how to write it. Like, wasn't that one of them? Limit is x. Yeah, look, this is your reasoning for that. Do you get what I'm saying? Like that answer's right here. You can just copy it over. All right, now we're on intervals. So from 2 to 5, and you want to include both the endpoints. Let me cover up everything from 2 to 5. That's no, and you only have to talk about where the problem is. F of 3 does not exist. There only has to be one issue to get it to be a no. All right, and then -9 to -6. So that's this portion here, and we're good on that portion. So that's just a yes. Okay, so your title for the notes that we're doing today, we're going to do limits analytically. So what that means is last time we did limits graphically. That means you had a graph and you just kind of looked at it and went, oh, there's the answer. Analytically means that you do not have a graph, which means it's more algebraic and more like more work, more writing. Some people do end up liking that better. They don't like graphs. So it depends on what your feelings are about that. Okay, so I have these in like little categories of how to approach the problem. So the first method, I have 4 different methods that we're going to look at, is that you're going to just plug in the value. Because sometimes that just works. And I will tell you from experience, sometimes someone will be sitting there for 20 minutes trying to like do all sorts of algebra and figure out a problem. And I'm like, did you plug in 3? And they're like, plug in the number first, okay? Because sometimes it will just work. So we're going to do a couple of these. I'm going to do like a couple from each category here so you can see what I'm talking about.
Would you count it wrong if I put like a division symbol between limit and the x to 5?
Let me come over and see what you mean.
I always do that. And I don't know if you can do that.
Oh, I wouldn't say call it. No. I would hope that they wouldn't on the AP exam either, because that's not really a division symbol. You're just like throwing a line in there. That's sort of just your
This is how I see
dialect. Yeah. Gosh, I would hope not. They on the AP exam, they accept all sorts of abbreviations. Like we're going to talk about theorems, like the intermediate value theorem is IVT. They accept that. You can abbreviate because B/C. You can abbreviate positive and negative POS. You know what I'm saying? Like they take all of those. So I would.
Like if there's displacement.
Oh, I threw a delta X in there because I've seen that show up. Instead of X, it'll be a delta X. Technically, it can be like whatever letter of the alphabet they choose to use as their variable. But I just wanted to throw that in there because sometimes you'll see that.
That's what I'm learning in physics right now.
Okay.
It's really hard.
Physics is really hard. I will agree with that. I went into physics thinking, oh, this would be a breeze because I'm good at math. No. It was not as easy as I thought it was going to be. Okay, so what you're going to do is just plug in the number. You ready? 5 minus 1. 4. And then down here, 5 squared is 25, plus 2, 27. Boom. That's it? Yep. Sometimes that's all it is. So always just try that first. And again, I threw these on here basically just to practice the notation, okay? And to review plugging things in. We're going to plug in 0 for our delta x. E to the 0.
1.
Fantastic. 1 plus 8. 9, square root of 9, 3. So again, I more threw that on there just to practice doing exponents and square roots. And then I threw this one on here basically just to review logarithms. Go ahead. Oh, yeah. The delta x is one item together. Like that is the variable is delta x. They do that sometimes.
Oh, okay, so just because like
yeah, like instead of x, it could be y or q, or they just made that one delta x. I've seen that show up, so that's why I threw one on there like that. Just keep them together. It's not 2 separate things. It's a package deal. So I threw this one on here just to review ln. ln of 1. 0. ln of 1 gives you 0, and then 0 plus 5 is 5. So again, that was really just to review logarithms more than anything else. ln of 1, any log of 1 gives you 0. All right, so let's do our second method. I don't have anything else to say about the first method. Plug in the number. If you get a value over 0, that means you have an asymptote. So if you get 3 over 0 or -5 over 0 or 12 over 0, that means that there is an asymptote in the graph. So think back to what we just did on the quiz review. The only way you can get an answer if there's an asymptote is if it's what? Sided. Okay, so if it is one-sided, you're going to test the denominator. I'm going to show you how to do this because the notes kind of don't make sense until we actually do a problem. You're going to test the denominator, and your answer will either be positive or negative infinity. Think about it visually. If there's an asymptote, it either has to go up or down. So if it's one-sided, you're going to test the denominator, basically just see if it's positive or negative. If it is not one-sided, then what is automatically going to be your answer? DN. So if it's one-sided, you just do a test, see if it's positive or negative. If it's not one-sided, you've got your answer. It does not exist. So we'll do a couple of these and then I'll do your break. Yeah, if it has a little plus, it's from the right. If it has a little minus, it's from the left. Okay, so you're gonna start by plugging the number in, and here's what gets people, because they get hung up on the fact that it's from the left or from the right. Still just plug in the number. Do you see how this one's limit is x goes to 2? Plug in 2. I realize it's from the left, but we'll deal with that later. Okay, just plug in 2. 2 plus 7, 9, 2 minus 2, 0. That's when your brain should go, oh, there's an asymptote. Okay, now you only test the denominator. We already know what the numerator is. It's 9. Okay, we're just going to test the denominator. So we're going from the left. Can you give me a number just to the left of 2? 1. You want to pick the next number because people will be silly and say -1,000. And I'm like, right, but remember for a limit how you zoom in really close to it? So you got to pick something that's close. Okay, so if we plug in 1 just to this denominator, 1 minus 2 is a negative number. And 9 is a positive number if you want to put the plus in there. So if you have a positive number divided by a negative number, it is negative and your answer is negative infinity. You're just testing if it's up or down. That's all that is. Because if there's an asymptote, it has to go up or down. Let's try it again. I know it says 7 from the left, but you're just going to plug in 7. If you plug in 7, what's your numerator? Right, -3 over 0. That's where your brain should go, oh, there's an asymptote. So we're going to plug in a number to the left of 7. Let's plug in 6. 6 minus 7 is negative, and our numerator is also negative. You don't have to test that. It's -3. We know it's negative. Now, if you have a negative number divided by a negative number, it's a positive number, so you get positive infinity. Try it again. If you plug in 4, you would get 12 over 0, and that's where your brain should go, oh, asymptote. What number do you want to try to test in the denominator? 5? Why 5? From the right. Okay. 5 minus 4 is positive. 12 is also positive. So it's positive infinity. And then the last one of these, if you plug in 10, you get 20 over 0, but you don't need to test anything. Why not?
Because there's no.
It's not sided, and so your answer is automatically DNE. So if you get a value over 0, it means that you have an asymptote. If you get 0 over 0, what do you think that means?
Undefined. Oh, 0.
Means that there's going to be a hole in the graph. Now, take away the thing that says limit and you're back to a regular old algebra problem. How did we find the holes in the graphs in algebra 2 and pre-calc? It cancels out. So you need to get something to use algebra to cancel out. You have to work until you get something to cancel out. These are the ones that have like some steps to them, like you have to actually do stuff. Once you get something to cancel out, then you can just go plug the number. Remember when we did that? Once you get it to cancel out, you take the number, just plug it back in, and that gives you the other thing. That's like, I mean, it's algebra, okay? The word for this is indeterminate. And that is a vocabulary word that comes up. Indeterminate. When you have a 0 over 0. In really advanced mathematics, there's all kinds of indeterminate forms like 0 over infinity and infinity to the 0 power and infinity over infinity and like all sorts of fun stuff. We're going to do 0 over 0. Now, as a heads up, if you plug in -1, you're going to get 0 over 0. But you still just want to always mentally check that, because this is what I was talking about, is people will try and do all sorts of algebra and waste all their time when they could have just plugged in the numbers. So here, let's just do that mentally. -1 squared. 1, it would be +5. So 6 minus 6 is 0. And then down here, you would have 1 minus 1, which is 0. But just think about it first. Now, when you go to your next step, you need to bring the limit notation with you. That's the only thing that makes it calculus. So you need that. Otherwise, it's just an algebra book. The other thing I always say about that, though, too, because people are like, do I have to write the limit? Well, yes. And if you don't, you'll probably forget to plug -1 back in at the end, because I see that happen all the time. People will do the algebra perfectly, cancel out, and then not get an answer because you have to plug that number back. All right, so how's the numerator going to split?
Yeah, 3 and 2.
Now, it can't be 3 and 2 because they would both be negative. So it'll be a -6 and a +1. Good. The other clue that tells you it's going to have a 1 in it is, how does the denominator split? Yeah, good. And you know something is going to have to cancel, so there's going to have to be a 1 in there. So the x plus 1s cancel, yay! And then you can go ahead and plug in -1 and get your answer. So for the numerator, that would be -7. And the denominator, that would be -2. So negatives cancel 7 over 2. So factor cancel out. I don't have too much else to say about that, because if I cover this up, you've been doing that for a long time now. Do you know what I'm saying? That's not really new information. We just threw a limit in front of it. No, it's not. H is the other letter of the alphabet that they'll use a lot. I like your comment. So if you were with me, I call these twins. Do you remember me saying twin? Something squared. You have 2 of them. Okay. I'm going to do this as a little side problem, like a margin problem. When you see this 4x plus h squared, what that means is 4x plus h times 4x plus h. Now, if you're like, I can do that in my head, cool, do it in your head. I'm doing the problem in front of a whole group of people that I'm trying to explain it to, though, so I'm going to write every last little thing, okay? So I just wrote that off to the side. I'm going to go to my next step, bring my limit with me. You have to write that. And then let's see what we get when we expand this. I call it FOIL, first, outside, inside, last. It's as long as you distribute everything, you're good. Here we go. 4x times 4x. It's 16x squared. And then I always do the outsides and insides together because they're going to combine. You would get 4xh plus 4xh, which would be 8xh. Very good. And then the last h times h h squared. Beautiful. And again, if you can do that in your head, fantastic. This isn't like required work. I just did it to show you what was going on. All right, so that's this first part. And then we have minus. Now 4x squared, what that means is 4x times 4x. So that's going to give you 16x squared. And if you're already seeing where we're going with this, then that's cool. And that is all over h. So what do you notice is going to happen? Those are going to cancel. So I'm going to need to come down to the next line with my limit. And out of what's left, but you only have two terms left in the numerator, what have they both got? H. So you're going to factor an h out. It's greatest common factor. You're just factoring an h out. That would leave you with 8x plus h over h. And those are going to cancel. And it's like, ding, 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 yay. Once you get something to cancel, then you're good. You have to do algebra until you get something to cancel, though. That's why these problems are a little bit like more work. And now you're going to plug in 0 for h. If I plug in 0 for h, what am I left with? 8x. Now, it does bother some people that there's a variable in the answer, but there was a variable in the problem. So, like, did you notice how there was an x and an h? So you're going to have one of them left over. Okay. I'm putting a square root in this one. It comes up. I have to show you everything that could possibly come up on your exam. I mean, I can't like skip that. Up to the first half of the year.
And we're gonna give it a big, so we have,
Yeah, I have a stuff to know, and it's like everything. I'm not even there that yet though, Haley. I didn't make it yet. I haven't even thought about it. So like, if I haven't even thought about it yet, you shouldn't be worried about it. All right. What you need to do is cancel out the root. Pep talk for this one. It's gonna be a teensy bit of writing on the like to start out with, but then like the problem sort of disintegrates and everything cancels out. You're gonna multiply by what's called the conjugate. You do teach it in pre-calc. You may or may not remember that word, but all you do is change this minus to a plus. So we're going to multiply by this square root of x plus 5 plus 3. And you have to do that to the numerator and the denominator. And you'll see what happens. It's all going to kind of cancel out, which is the goal. Like that's the point. But you multiply by the conjugate. So bless you. When you come to your next step, bring your limit with you. And I'll talk you through how this cancels out here. We're going to do FOIL again for this first outside, inside, last. When you multiply root of x plus 5 times root of x plus 5, you just get x plus 5. The roots cancel. Isn't that lovely? All right, watch what happens next. The outsides would give you 3 square root of blah, blah, blah. The insides would give you minus 3 square root of blah, blah, blah. So what happens to those? Yeah, they cancel. Again, that was the whole point. And then you have negative 3 times positive 3, which is negative 9. Listen carefully to this. What should you do with the denominator? Nothing. Nothing. Do nothing. Just copy it exactly like it looks. Only you might want to give the x minus 4 a hug. Like just put some parentheses around it. I call that giving it a hug. And we're practically done with the problem. Because I want you to look through it. What do you notice is going to happen? The numerator is really an x minus 4. Are you seeing that there? X plus 5 minus 9, that is x minus 4. So they cancel. Ding, 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 ding. Once you get something to cancel, then you're good. Now, sort of tricky, though. What's still in the numerator? 1. Okay, so the numerator is 1. The denominator, you're going to plug in 4. Make sure you bring the limit with you so you remember that you're supposed to plug that in. So 4 plus 5 is 9. Square root of 9. 3 plus 3 is 6. So 1 6. So you got to do algebra until you get something to cancel out. So let me just review. We have one more method. Let me review everything. And we'll get it done before lunch. What do we have, 10 minutes? Perfect. Plug in the number. That's what you always want to try first. Value over 0 means an asymptote. You're testing positive or negative, or if it's not sided, it's no answer. Does not exist. 0 over 0 is indeterminate, means there's a hole, you have to get something to cancel out. If none of that works, your last ditch effort, like your Hail Mary, is draw a graph. You don't have one, draw one, and then just look at it. If you cannot figure it out, just draw a graph. All right, what number am I on? 11? And this is why we went over like all those functions and how to graph them. Is for this. If you need to be able to do limits and you need a graph, you have to know what they look like in order to get a graph. So if you tried to just plug in the number with something like this, you would get ln of 0, which isn't a thing. Okay, so we're going to draw a picture. Basically, what does an ln graph look like? I accept hand motions. You know this thing? Like the sideways swoop? Okay, but it moved what direction? 2 to the left. Okay, good. So go 2 to the left, dot that in, and it's going to look like that. Now it's good we're approaching -2 from the right. Why couldn't you approach it from the left? There's nothing there. If you approach -2 from the right, where's your graph headed? -infinity. Now, if you can get the answer without drawing the graph, great. I had to draw it because you can't reach inside my brain and see what it looks like. So. These graphs look cool. And it actually comes up in the end of unit 2. I talk about these graphs a little bit more. So I like to throw one here as foreshadowing. Let me show you what it looks like because they're neat. I like them. If you try to plug in 0, you get 0 over 0. It ends up not being a hole in this case, though, because these graphs are just a little bit wacky. Come with me on this thought journey. If you plug in 1, you get 1 over 1, which is 1. If you plug in 2, you get 2 over 2, which is 1. And 3 over 3, that will give you 1. So you will get 1 forever if you go this way. You're just stuck at 1. Hold on a second. Now I'm going to go the other way. If you go the other way, the same thing's going to happen, but instead of being at 1, you're going to be at -1. So the graph looks like this. Did I show you one last year? I tried to throw them in there because it comes up.
Wait, so that's absolute value, just so
That is an absolute value in the numerator. So if you're approaching 0 from the right, you're coming from this side, your answer is 1. If you were approaching from the left, -1, and if it wasn't sided, does not exist. If you don't want to write this one, that's fine. I just want to show you this really quick. And then I have one more, okay? Just to like solidify your understanding. If you want to just watch, that's fine. I'm going to take a picture of this and post it. This is this graph shifted right 4. Do you understand your transformations? Right 4. So it would look like this: 1, 2, 3, 4. And then you'd have your lines at 1 and -1. And then what would be the answer if you're approaching from the left? It would be -1. From the right, it would be +1. And then the last one, I'm going to throw a step graph in here just because you guys love it. And it might come up, you know, so. They like throwing these ones at you because they're very disjointed and weird looking.
So is it brackets, absolute, and then the X?
So it's technically supposed to be bold font. The bold feature on my pencil is broken. So I put like a double one there. It's technically just supposed to be bold. Does that make sense? Like, it's not an absolute value. It's like a double bracket. You can draw like 2 of them. It's supposed to be bold font, but I can't write in bold.
It's so random.
Yeah, I don't know. Anyway, so it's your step graph. Last one, guys. It's your step graph moved up 1. So you're gonna go up 1 and put a point, and that's where your first staircase is. I didn't draw that open circle very big. Let me make that a little bit bigger. And then you can just keep going with your stairs. Now you want to draw a few of them because the X value we're looking at here is 3. So you want to go like at least that far. And I'm just gonna you don't have to do this if you don't want to, but I'm just gonna number them so that when I point to it, we have some values there. Here's 3. Are we approaching from the left? Okay, so watch me point to this. I get that there's a hole there, but if you're approaching from the left, you're still on this step, so it would be 3. Real quick, if you were approaching 3 from the right, it would be 4. And if you were approaching 3 overall, DNA.